This is Unit 4, Lesson 13, Solving Systems of Equations, and this is practice problem number 2. And in this problem, you're supposed to find which pair of equations and which pair of graphs have this coordinate, 5, -19, as a solution to that system of equations. And probably the easiest way to approach this problem is just to replace the x value with 5 in each case and see if you get y equals -19. So replace x with 5 and do that all the way down. So when I replace this x with 5, I get -21, -13. So C, I get -19. So when x is 5, I get -19. This is -12, and E, I get -19. So that means that the solution to the system of equations of C and E is 5, -19. If you look at that on a graph, so I graphed each one of these. I'm going to show you how I did that in just a moment. But if you go to 5 units along the x-axis and you go down to, this is -12, -13, and 2 are at -19. So that's the solution between C and E. And then -21. So those are the same y coordinates that I got here. -21, -13, -19, -12, and another -19. So to graph each one of these, I just went to the y-intercept, which is -6, and then I looked at the slopes. So for each unit in the along the x-axis, you go down 3 units. So it's 1 over or 2 over and down 6 units, 2, 4, 6. Same with 4 over or and up 12 units, 2, 4, 6, 8, 10, 12. And so it's the same thing every time with each graph. For B, it's the same thing. The y-intercept is -23, and so for every unit along the x-axis, you go up 2. So if you go over 2 units, you go up 4, 2, 4. If you go to the left 2 units, that's a -2, and it would be a -4. C, same idea. Go to the y-intercept, which is way up here. -7 units for the slope. So that's -14 every 2 units, -14, 2 units, -14. D, the same idea, but this has a slope of 1. So the y-intercept is -17, 2 units over, 2 units up, or a -4 units and a -4 units. That's a slope of a +1. And for E, same idea. Y-intercept is -9, and the slope is -2. So 2 units over, 4 units down. 4 units to the left, that's a -4. And then you're going to go up a +8 units. 2, 4, 6, 8. And here is the solution to C and E, getting rid of everything else. So there's the common point, the point of intersection. The solution to that system of equations is 5, -19. So what that means is that every point on a line is a solution to that equation. So all of these points on this line are a solution to that single equation. All the points on this line are a solution to that equation. But the intersection of the two graphs is the only point that is a solution to both equations, and thus a solution to the system of equations. So for a value of x, y is the same value for both equations, -19 in this case. So 5, -19. It's a good idea to graph all of these and to solve for the system of equations of each pair. So A and B paired together, A and C, A and D, A and E. So there are 10 of those intersections, 10 of those solutions for different pairs of systems of equations. And this was hard for me to look at for a while, and I realized after a while that it is 10. And so I numbered each of them, and I'll show you how these numbers correspond to the equations and graphs in just a moment. But then to make sure, I made a little tree diagram. So if this is A, A intersects with B, C, D, and E. And if this is B, B is already intersected with A, but B then intersects with C, D, and E. If this is C, C has intersected with B already, A already. This is D and E. If this is D, D is intersected with C, with B, with A, and then it intersects with E, and E has already intersected with A. So there are 10 different intersections. So if you pair each of these, so A paired with B. So you look on this, this is A, so it goes by color. So A and B. So that's intersection number 1. So this is going to be intersection number 2, right here. A and C. This will be intersection number 3, A and D, which is right here. There actually are 3 intersections very close to each other. And intersection number 4 is A with E. So 4 is in this mix of 3 points as well. So A with E, which is the orange. With practice, you're going to see that it's not that hard to solve the system of equations. So here's an example for the solution of C and E. So I'm going to look for the difference between the y-intercepts and the difference between the slopes. I'm going to divide them, and that's going to give me the x-coordinate, and then I'm going to use that to figure out what the y-coordinate is. So the difference in the y-intercepts, I'm going to start with -9, -9 minus 16. And that means I'm going to go up here to -7 minus a -2. So if you choose to go this way, then for the slopes, you're going to go the opposite way. This is the algebra that you're going to do, but I'm just doing it in my head. And I'd like you to practice doing it in your head. So -9 minus 16 is the difference in the y-intercepts. That's how far they are apart. And then the difference in the slopes, -7 minus -2 is -5. That's how much the gap, this -25 units, is closed for each unit of x. So you take out a -5 units from this -25 for each unit of x for each unit along the x-axis. So how many times can you do that? That's this -25 divided by -5. And so x is equal to 5. And just take that value of 5, plug it back into either of these equations. So -7 times 5 is -35, plus 16 is equal to -19, which is y. It is not that hard to do with practice. It looks hard in the beginning, but then practice it and you'll see that it's not that bad. So y is equal to -19, so the coordinate xy is 5, -19. 5, -19. Here are all the intersections. Here's the tree diagram that I used to check that I was getting all the intersections, that I was labeling them all. So what I'm doing is finding the difference in the y-intercepts, and I'm going to use one that's a little bit harder. I'm going to find the solution between B and C. So that difference in the y-intercepts, 16 minus a -23, and then it's going to be 2 minus a -7. So 16 minus a -23, and the difference in the slopes is 2 minus a -7. So you work through that arithmetic. This is 39 divided by 9. So find the difference in the slopes. +9. Then divide to get the value of x. How many times can I take out 9 units from 39? This is the difference in the y-intercepts. This is how many units I'm going to take out for each unit along the x-axis. So how many units of y am I going to remove from 39 for each unit along the x-axis? And it's going to take me 4 3/9 times to close that gap completely. So 39 divided by 9, 36 divided by 9 is 4. You're left with 3/9. So this is 4 1/3. And then replace x in either equation to get the value of y. So either b or c, I'm going to replace x with 4 1/3, 4 1/3, and I'm going to get a value of a negative 14 1/3. So what I did here is I multiplied 7 times 4 is 28, it's negative 28. 7 times 1/3 is a negative 7/3. So I used the distributive property just to split these out to make it easier. So this is a negative 28 plus a negative 2 1/3. 7/3 is 2 1/3 plus 16. So add these two together. It's a negative 30 1/3 plus 16. So I'm going to split out this negative 1/3. I'm going to put it over here for a moment because it's easier for me to add 30 plus 16, or a negative 30 plus 16. So that is equal to negative 14. Still have this negative 1/3. Add them together. So the y coordinate is equal to negative 14 1/3. So the solution is 4 1/3 between b and c, 4 1/3 for the x coordinate, and a negative 14 1/3 for the y coordinate. You do the same thing every time. So these are the solutions for c and d, c and e. So the color is following this color up here, and the color of the graphs is the same. It's these colors, all these colors match. And this is the solution right here between c and e, the answer to the question. So this is number 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the 9th intersection, and then the 10th intersection. Practice. You have to practice to be able to do these basically in your head.